Hey y'all, in this lesson we are going to look at understanding the y-intercept of a line. So our goal is to be able to analyze graphs in context to determine and explain the meaning of the y-intercept. Fill in these missing words in your notes. The y-intercept is the y-coordinate of the point on a graph where the line crosses the y-axis. Remember that the y-axis is the vertical axis, so it goes up and down. So let's take a look at some problems identifying the y-intercept. As we look closely at this first problem, we can see that it looks like the line is crossing the y-axis at the number 2. So the point is 0, 2, and we say that the y-intercept is 2. Let's look at the next one. Again, we're looking at what number it crosses the y-axis. As we look here, we don't have a number labeling this spot where it's crossing, but we do see that 2, 2, so it's because all of these are going by 2, that means this must be 1, or because it's down, -1. So our line crosses the y-axis at the point 0, -1. So we say the y-intercept is -1. As we take a look at the last one, we can see that this line goes right through the middle where the y and the x-axis come together. And this crosses at the point 0, 0. And here we say that the y-intercept is 0. Keep in mind that this does not mean that the y-intercept doesn't exist, but that its number value is 0. Now you try reading these two graphs in your notes. State what is the point of the y-intercept and what is the y-intercept. Our second example, we will be looking at this graph. This graph is showing a robotic assembly line that is manufacturing a set number of parts per minute. We'll use the graph to verify how many parts the assembly line manufactures when it is first turned on. So the first step we're going to do is make a prediction. Think logically. The machine has not made any parts when it is first turned on, right? You flip that switch, it turns on, it hasn't made any while it was turned off. So the answer should be 0. We should be expecting 0. Now we take a look at our graph and see where it crosses the y-axis. Because the y-axis is going to represent 0 minutes, it will show how many are made when it is first turned on. We see from the bubble and from the pointing arrow that the point, the y-intercept, does look like it's at 0. That agrees with the prediction we made, and 0 parts are manufactured when the robotic assembly line is first turned on. So our answer makes sense. Let's look at another relationship. Matilda and her friend are going bowling. She can rent shoes at the bowling alley or use her own. How can she determine how much money she'll save if she brings her own bowling shoes? Okay, so basically looking at, is it worth it? Well, our first step is to write the number of games and the cost as ordered pairs. So we can see over here, 1 game is $4. 3 games is $8. We can write that 1 game, $4, and that can be a point. So what we will write all of our points like this, and then graph those ordered pairs to find the slope. Here is the graph from those ordered pairs. 1 game is $4, 3 games is $8, and so on. To calculate the slope, we want to look from one point to another. I'm going to look at 3.8 to 5.12. When I start looking at the slope, I want to know what is the run or how much it moves over, and what is the rise, or how much it moves up. I can see in blue that the rise can be found by doing, or the run can be found by doing 5 minus 3, and the rise can be found by doing 12 minus 8. We get 4 for the rise and 2 for the run, so I have 4 over 2, or when I divide that out, is simply 2. That means the slope is 2, and so the thing that's changing the number of games it's going to cost each game is $2. Using that slope, because every time, every game it goes up $2, we could also say every less game it goes down $2. So we can extend our line, and we know that because one game is $4, if we take off that one game, or $2, we can see, and it makes sense with where it's crossing, that the y-intercept here is 2. Since this is where they play 0 games, that means that that starting point is the cost of the shoe rental. So the cost of the shoe rental is $2. This means that Matilda saves $2 if she brings her own bowling shoes. So we use the slope to extend our line to know when it will cross. Here is an example for you to try. These prices for a different bowling alley are shown in the graph. How much does the bowling alley charge for shoe rental? So you can see the points, and they are labeled with their X and Y values, so you can figure out the slope. You know that one game is $4.50, and so using the slope, go backwards 1 to figure out how much the shoe rental is. Here is our summary. The y-intercept is the y-coordinate of the point on a graph where the line crosses the y-axis. We have 3 different scenarios. When the line crosses through the origin, the y-intercept is 0. We see that here. And the y-intercept is always 0 for proportional relationships. When the line crosses above the origin, the y-intercept is positive. When the line crosses below the origin, the y-intercept is negative. Your next steps are to submit your 3.4 notes, complete your build 3.4, take the 3.4 mastery check, and you can move on to the next lesson. Good luck.